Okay, good morning, everyone. Questions? Any questions from the homework before we get going? Chris, 17, 56, 63. Which section, Chris?
I'll check on now.
Okay. I think it was point 2. Okay, I think it's 12.2. Good morning, Isaiah. So we will do number 17. Sketch the following sets of points. Theta equal Chris is 12.2, right?
I believe so, yeah.
Okay, theta equal 2 pi over 2. So we're going to sketch all the points whose polar coordinates satisfy theta equal 2 pi over 3. So it means that R could be anything. That's what it means. It means we're going to draw all the point R theta, where the theta is 2 pi over 3. And the R could be anything you want. I mean, there is no restriction of R. So R could be 0. So we pick up this point. R is 1. Theta is 2 pi over 3. So if we draw 2 pi over 3, just 120 degrees, so R could be 1. So we pick up this point. R could be 2. We pick up this point. R could be minus 1. We pick up that point. R could be minus 2. We pick up that point. So it's going to be all the point that lies on this line. Okay, so this theta equal to pi 3, all of them, because every point here, no matter which point you take, if you take it in the fourth quadrant, the angle is 2 pi over 3. The R in this case is negative. So this pick up the negative R, the angle 2 pi over 3. If you take those points, we pick up the positive R, but the angle is 3 pi over 3. So it's the whole line. All the line that form an angle of 2 pi over 3 with the positive x-axis. Okay. Now let's look at 56. So we have to sketch R equal 1 minus cosine theta. Okay, and we're going to do them like we did last time. First, we're going to have two graphs. The first graph is the R theta graph. So this is the theta, and this is the R. And on this graph, I'm going to sketch how is R changing with theta. Okay, R is 1 minus the cosine. Minus the cosine is like this. So minus cosine is, the cosine start here, go like that. That's the cosine. The minus it is going to start at this point. This is reflection. And 1 minus is going to shift it up by a unit. So the x-axis is going to be shifted up by a unit. This is what we're going to usually call the midline. And then minus 1 will be shifted up to 0. And then that's going to be the graph. And then it's repeat itself. So we pick up some value. That's the 2 pi here. Right there. And then it peaks. That's the pi. This is the pi over 2. And finally, the 3 pi over 2. So that's the value of R as a function of theta. Now the polar plane. So right here, we have theta equal pi over 2. I mean, that's the theta equal to 0 line. And right here, that's the line theta equal pi over 2. Means every point here, its polar coordinate have theta pi over 2. And this is the polar plane. And now we start translating from here to here. If theta is 0, R is 0. So we're going to start right there. If theta is pi over 2, R is 1. Between 0 and pi over 2, R is positive, so a theta sweeps this region. That's the way I think of it. Theta sweeps this region. R is positive. It means my point is here, and it's increasing. So it started at 0, is increasing, 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 increasing up to 1. Now, at pi, R is 2, and R is still increasing. So R is increasing. So a theta is, now right now, theta is between pi over 2 and pi. Theta is increasing all the way to 2. So this point is 2 and pi in polar. And then when theta is between pi and 3 pi over 2, R is decreasing, and at 3 pi over 2, it is at 1. So now the symmetry starts, and finally, we look back like that. Okay, that will be the graph of in polar full length. Okay, questions? Okay, now finally, we look at 63. We have R equal sine 3 theta. Okay. And we have to sketch the graph of this in R and theta. All right. Question number 1. This is, we have to sketch the graph in the Cartesian plane, how R changed with theta. And once we do that, we sketch it in the polar plane. Now, last time I mentioned something. Sine of 3 theta. It looked like sine theta, but the period is different. What's the period for this function? Anybody remember? What was the period? Anybody remember the formula for the period? It means how long it takes for the function to start repeating itself. Anybody has any memory?
Was it 2 pi over b?
Right. And what's the b here?
B is the coefficient of the angle.
Which is 3. Exactly. So the period here is 2 pi over 3. Means this is going to repeat itself every 2 pi over 3. So the graph would look like that. Okay. So this is theta, and these are the value of R. Okay. So it's just like sine, but that's how often it repeats itself. So it's going to start at 0, and then it goes up, back, up, but right here, this is 2 pi over 3. Okay, because when you take 2 pi over 3, watch carefully. If you take 2 pi over 3 and you plug it in here, plug it back in here, you get 3 times 2 pi over 3. It means 2 pi. So when theta is 2 pi over 3, you get here sine of 2 pi, which is going to bring me back to that. Then it starts repeating. So we're going to cover it from up to 2 pi, because after that, because we have to go all around, and then it repeats itself. So we're going to erase this. So right now, 2 pi over 3 plus 2 pi over 3. So this point is 4 pi over 3. And finally, it repeats itself one more time. Go up, down, up. 4 pi over 3 plus 2 pi over 3. This is the 2 pi. So it repeats itself 3 times between 0 and 2 pi. Okay. Now, always, whenever you're graphing, you should know where R is 0, because they really guide us into the graph. Now, when is R 0? If this is from here to here to pi over 3, that's halfway through. So that's the pi over 3, 2 pi over 3. So by symmetry, there is pi over 3 here. So it's going to be the pi, 4 pi over 3, and this is 5 pi over 3. Okay, so that's how theta changes with pi. Now we're going to take that and verbatim translate it into the polar plane. And this point, you imagine, this is the pi over 6, just because that's halfway through. Okay. So now I'm going to translate this verbatim. All right, so right here, I'm going to take the polar plane. So I'm going to do that, so we see both of them. So now the polar plane. So this is the line, theta equals 0. And this is for me, theta equal pi over 2. And I'm going to translate it. Now, R is 0 at pi over 3. And usually my advice to you when you graph those is draw the line theta equal pi over 3. So theta equal pi over 3 is somewhere here. So I'm going to draw those lines because I know that r is 0. So it's important to emphasize them. So always start drawing the line when theta is r is 0. Another place, it's 2 pi over 3, which is going to be right there. 2 pi over 3. Okay, those give us a good limit for our theta. Now 4 pi over 3 is going to be the same as pi over 3 because you're just adding a pi. And 5 pi over 3 is the same as 2 pi over 3 because you're adding a pi. And now we're going to start graphing. If theta is 0, r is 0. If theta is, and then theta is increasing. Sorry, r is increasing. Increase, increase, increase. It has a peak at pi over 6. So somewhere here at pi over 6, it has a peak. And r increases, reaches its peak, and then it decreases up to pi over 3. Okay, so now we know the limit. We know exactly the limit. By drawing those lines, we know the limit of our piece. So that's the first piece in my problem. Now the second piece, between 2 pi over 3 and, sorry, between pi over 3, it means that theta sweeps this region. Okay, theta sweeps this region. Where is my r? So at pi over 3, I am at 0. At 2 pi over 3, I am at 0. And in between, r is negative. It means that if I take theta here, r is negative. The point is going to be in the opposite quadrant to it. If I take theta here, r is negative. We're going to be down here. So between pi over 3 and 2 pi over 3, the graph will not be in this region. It will be in the opposite region. It will be right there. And now at pi over 3, I am at 0. Halfway through, I am at -1, which is give me at pi over 2. So I am at 0. Between here and here, my r is going all the way to this way. And then between, this is going to be pi over 2, if we do a little bit the math, between pi over 2 and 2 pi over 3, my r is always negative. It starts at -1, and then it's getting less and less negative, heading towards 0. And we get this piece of the problem. Okay, so this point down here corresponds to -1 pi over 2. That's this point down here. Now we keep going. Between 2 pi over 3 and pi, what's really happening? 2 pi over 3, I am right here. Pi is pi, right there. R is positive. So my points are in this right there because R is not negative. So if theta go from pi over 3 here to R is positive, it means my graph is in this region. And what is my R doing? It's starting at 0, halfway through, so it increases, reach its max, and then it backs up. So that's the third leaves. So those are leaves, as you guys can imagine. Okay. So then I am up to pi. And then after that, what's happening? The graph is going to start repeating itself. So what's happening after that? Between pi and 4 pi over 3. This is my pi, and this is my 4 pi over 3. Between pi and 4 pi over 3, my r is negative. So if theta go from here all the way to here, the points are going to be in the opposite region. Since they're not going to be here, the points are going to be here because my r is negative. So at pi, I am at 0. Halfway through, right there, my r is -1. So in between, my r is 0. Instead of the graph moving in this region, it's going to move in that region. And it's going to go over this one again. So it will go over once. And then halfway through to 4 pi over 3, it's going to go over this region one more time. So it's going to circle this region twice. And then between 4 pi over 3 and 5 pi over 3, this is positive. I'm going to have no issue with that. It's going to go over that. And then finally, between 5 pi over 3 and 2 pi, my r, instead of the graph being in this region, the graph is going to be in the total opposite because my r is negative. So it's going to start this way and then back up. Okay, and then we get this graph, right? Questions before we move on? Questions? Okay, So try to do that. I tell you ahead of time, one of the way I check the student to make sure they can interpret that is instead of giving you a function or a rule, I will do this for one problem. Another problem, I'm going to do the following. I'll tell you ahead of time what I will do. I will give you theta and r, and I will give you a certain graph. You know, I can do something like that. And I tell you, this is the graph of r as a function of theta, translated to the polar plane. It means use this info to sketch the graph in the polar plane. So that's the kind of question I will ask, just to make sure you guys understand how we translate this picture to that picture. Any questions before we move on? Right. So today what we're going to do is the following. I am gonna skip section 12.3 and I'm gonna move to section 12.4, conic section. So 12.4, conic section. Okay. All right, and before I do that, I'm not following the book for this section. So for 12.4, I'm not following the book. I put on the announcement on Brightspace a link to the chapter I'm going to use. I'm going to use a very basically simplified version of conic section, which is what I think you guys will need. And so it's already on Brightspace. And the homework that I will assign for this particular section, which is, as you realize, it will be an easy section. It's pre-calculus material. And the problem I will assign for this section will not be from MATLAB because they do not coincide with the way I'm doing it. They will be from the summary I gave from the chapter I gave you online. So the way I will do it every day, I will assign like 2 or 3 problems, whatever problems from the section. They will not be MATLAB problem. They will be from the notes I gave you on Brightspace. MATLAB, I will keep assigning problem from it, but it will be for the review material. So you're going to have 2 sets of problem. One, MATLAB. We're going to have MATLAB, which will be basically the review material. And then you will have homework, not from MATLAB, from the notes on Brightspace. And then every day on the announcement, I tell you, do problem, blah, 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 from the book. So homework from the online, from the section on Brightspace, section on Conic.
When is the final for this class?
What?
When is the final for this class?
The final is next Monday. Right now, next Monday, you guys will be taking your final.
Okay.
Okay, actually, I did send you everything. I sent you an email with everything. On Brightspace now you have a review for the final. You have the answer to the review, what you're responsible for, the time. So the exam will start. It's next Monday. It opens at 7:30. It closes at 10:30. It's comprehensive. You're responsible for everything. The only thing I will omit from the final is integration by trigonometric substitution. It means the integration where you do like x equal 2 cosine theta, x equal 5 secant theta. That's the only one I will omit from the final because you don't have a lot of time to study. And I want to concentrate on the integration technique that you will need the most, mainly substitution by parts, partial fraction decomposition, and trigonometric integral, which is substitution. But you will not have x equal 2 cosine, x equal tangent. This will not be on your final. That's the only thing I will omit. All right? Okay, so conic section. What are conic sections? Conic sections are the following. If you take a cone, I will try to draw the best I can. If you take a cone, just a simple cone like this. Okay, and a cone. Not one cone, 2 cones, something like that. So one cone this way. So where the word conic section coming from? Okay, and let us assume it goes on infinitely from both sides. Okay, and where the word section is really coming from, the following idea: you take a cone, and let us say you take a horizontal plane, and you cut this cone. All right, just cut it. What do you get? Just imagine a little bit. What do you get? You have this cone, you cut it horizontally. What's going to be the intersection of the plane with the cone. What do they intersect? Okay, Elizabeth tells me it is a circle. Absolutely. Okay, you get a circle. Now, you take the cone, exactly the same cone, and you cut it with a plane, the same plane, but instead of being horizontal, just you tilt it a little bit. You do it like that. Okay, and what's going to be the intersection between the cone and the plane? So instead of make this directly horizontal, you just kind of tilt it. What do you think the shape you will get?
Won't it be a rectangle?
No, if you imagine the cone. There is no way you can get a rectangle out of a cone. It's a cone. You're going to get an ellipse, an oval shape. Okay, imagine a cone. The cone is circular. All right, the cone is totally circular in nature. So there is no way you can get a rectangle out of a cone. So if you take it horizontally, you get a circle. Tilt this a little bit. Okay, tilt it a little bit. What you're going to have is an ellipse. Now, these are what we're going to call conic section. It's the circle and the ellipse. Now, the other way we can cut the cone is like this. So this is my cone. Again, that's a circular picture. It's a double cone. Okay, so we take a cone. And this one, we're going to cut it vertically. It means I'm going to take the plane and cut it in a vertical way. Okay. And now what do we get when we do that? What do we get when we do that? So this is probably harder for you. We get something, if you can imagine. So this is a vertical cone. We're going to get a piece like that in the top. And in the bottom part here, we're going to get a piece like this. So if you take a plane which is horizontal and you cut it, you get two pieces like that. And this is what we will call hyperbola. Okay, so conic section are the ellipse, and that's where the word conic is coming from. And section, it means when you take an object and you cut it with a plane. The intersection is called a section. So if you take this cone, you cut it horizontally, you get a circle. You cut it, it's not horizontally, you tilt the plane a little bit. Just tilt it a little bit, it gives you ellipse. That's a conic section. And then finally, if you cut it by a plane which is totally vertical, you get what we call hyperbola. So that's why those two things we're going to study, circle, ellipse, and hyperbola, are called conic section. In that way, yeah, we get it very easily. We get a parabola, but I will not talk about it. You get a parabola this way. You take the plane. It's not horizontal, it's not vertical, and it's not tilted this way. It's tilted like this. This kind of a plane. If you take this plane, you get the honest to goodness parabola. This is another conic section. Okay, all those are called conic: parabola, circle, ellipse, and hyperbola. Parabola, you guys know its equation, so I will not dwell over parabola. Sy equal ax squared plus bx plus c. So I will not dwell over that. I'm going definitely to remind you the circle. I will spend a few minutes on the circle, and then we're going to study ellipse, and we're going to study hyperbola. Okay, and those are crucial. I mean, they are crucial for you to know the equation, how they look like, and all about them. Right? Any other questions? Okay, very well. So now today I'm going to start with circle. I mean, I will go to circle, of course, fairly simple. And then I will start with ellipse. And tomorrow we'll finish ellipse and we do hyperbola, hopefully. Okay, so circle. And the note I gave you, don't talk about circle, simply because I assume you guys know all about circle. So they do not really even mention it. So what is a circle? So a circle is obtained the following way. We fix a point. So we fix a point, coordinate hk, so we fix a point, and a number r positive. And the circle, by definition, is all the point P. So let me give this point, this C, all the point xy, such that the distance The distance from P to C is a fixed number R. So a circle is, so you fix a point R positive, a point C. I'm going to fix this point, HK, and the circle are all the points whose distance to here is R. So I take this point and I draw all the points whose distance to the center is R. Okay, all the points P that satisfy this condition. So all the points. So there are infinitely many points. And we get what you guys know, an honest to goodness circle. Okay. So now what's the equation of a circle? What does it mean, the equation of something? Equation of a circle means if you take any point on the circle, this point has coordinate, X and Y. Finding the equation means finding the relation that exists between X and Y. Okay, so find the equation of the circle means what's happening. If you take a point on the Y, what's going on? What's the relationship between the X and the Y? To find the relationship between them, we say, okay, what characterizes this point? If you point on the circle, what characterizes it is the distance from here to here is equal to R. That's what characterizes the point. Now, what's the distance from here to here? So we're going to compute the distance. So distance from the point P to C is equal to R. That's really what characterizes the distance. But now what's the distance between 2 points? Do you guys remember the formula? We take Pythagorean theorem all the time. Pythagorean theorem tells me the following. This side, this square plus this square is equal to R. But how much do we have from here to here? Can anybody tell me using the picture? What's this vertical displacement? This is how much we have from here to here. Quickly, all of you. Look at the picture. How much we have from here to here? Anyone?
Would it be X minus H?
Exactly, it's X minus, no, sorry. The vertical one, not the horizontal.
Y minus K.
Y minus K. This is Y minus K. I mean, that's the change in Y if you want. Basically, if you look at the picture, this is the Y and this is the K. So this is the Y minus K. And now how much do we have from here to here? This horizontal displacement. This is my X.
That's the X minus H.
That's the X minus H. Okay, the vertical one. And now I use this. So Pythagorean theorem tells me that Y minus K squared, and this only characterizes the point on the circle. If you take a point inside, the distance from here to here is not R. If you take a point here, the distance from here to here is not R. Only the point on the circle satisfies. So this is going to give me plus X minus H squared is equal to R squared. So any point on the circle, what's the relationship between the X and Y? The relationship between X and Y is given by this equation. Why? Because that's this on the circle. It means the distance from P to C is equal to R. So the equation of a circle now becomes the following. And it's very easy to derive. It's just Pythagorean theorem. So equation of the circle become exactly centered at HK with radius R is given by X minus H squared plus Y minus K squared equal to R squared. I mean, this should be absolutely drilled in your mind, period. Okay. In particular, if the center is the origin, if center is the origin, then the equation becomes X squared plus Y squared equal to R squared. Okay. That's equation of a circle. So whenever we see this equation, we should recognize a circle. We see that equation, we should recognize really a circle. So two straightforward application, I mean, not application, examples, two straightforward example. So A, find equation of the circle. Centered at, let us say, the point -1, 2 with radius 4. Okay, so basically, as I said, it means if you take the circle where the center is -1 and a 2 and the radius is 4, so it's going to be something like that. That's the radius. Finding the equation, it means you take any point on the circle and you're giving me the equation that relate the x and the y. So if I know the x, I know the y. If I know the y, I know the x. So we apply this formula verbatim. H here is -1, so that's going to give me x plus 1 square plus y -2 square is the radius square, which is 60. Okay, that would be the equation of the circle. So now if you take any point on the circle, if I give you the x, you can use the equation to find the y. If I give you the y, you can give the equation to find the x. So that's the relationship between any 2 points. Okay, example number 2. Find center and radius of. So suppose I give you the following equation. X -2 square plus y plus 4 square equal to 2. What's the center? What's the radius quickly? Okay, what's the center here?
Isn't it 2, -4?
Yeah, what's the radius?
Square root of 2.
Square root of 2. Okay, because this is r square, it means the radius have to be square root of 2. Okay, all right, so that's the circle. There is not much I can say. It's just that's the equation of the circle. In Cartesian coordinate, absolutely. In polar coordinate, we know that the circle in polar is much simpler than that. It's just r equal, like if this circle, in polar coordinate, a circle centered at the origin. So if I want to say centered at the origin, x squared plus y squared equal to 2, in polar coordinate, centered at the origin will become r equal to square root of 2. So that's very simple in polar coordinates. Part 2 is ellipse. First, what is an ellipse geometrically? And then what's the equation of the ellipse? So ellipse. Okay. So before we see what the definition is, I mean, what the formula is, first, geometrically, what is an ellipse? The ellipse is the following. It's basic graphically, it's just the circle squashed a little bit. So the ellipse is just you take the circle, assume this is a circle, and you squash it, you get an ellipse, which is this oval shape. That's really what the ellipse is. But geometrically, what is ellipse? So definition. Okay. We're going to fix, in the circle, we fixed 1 point, the center. Now we fix 2 points. We're going to fix 2 points. F1, we're going to call this point F1, and F2 in the plane. And a number A positive, and a number A positive. Okay, so we're going to fix 2 points, F1, F2, and a number A, which is a positive number. So we fix point F1.
What does it say after A?
Yeah, I knew
in the sense?
I knew I didn't write clearly. And a number, thanks. Just a number, A positive.
Okay.
Yes, thanks. All right. So now we fix 2 points, F1 and F2. Okay. Ellipses. The ellipse will consist of all points P coordinate x, y, all pointed such that first I tell you the picture. It consists of all the points such that the sum of the distance from this point to F1 plus from P to F2. So all the points such that from P to F1 plus the distance from P to F2 is a constant number that we call 2a. Why 2a, not a? Because the formula is easier with 2a. So it consists of all the point P such that the distance from P to F1 plus the distance from P to F2 is a constant number. So this notation here, this means distance from P to F1. And this is distance from P to F2. Okay. So what is an ellipse geometrically? You fix 2 points. Those are fixed. And you take all the points such that from P to F1, the distance, plus distance from here to here is a fixed number is equal to A. Now, suppose I give you this point P, and I tell you this point is satisfy this condition. Another point that will immediately satisfy this condition is this point right here. Why is that? If PF1 plus PF2 is 2A, if I take this point which is symmetric to it, the sum, this from here to here plus from here to here will be equal to 2A also. Another point which will be on the ellipse is the point symmetric to it right there. If I take a point which is totally symmetric, this also point will be on the ellipse because it satisfies the same condition. If I sit down and draw all the points such that the sum of the distance, I will get this shape. If I take all the points, I will get exactly this shape right there. Okay. Now, you can find on YouTube a lot of videos that actually show you how you construct an ellipse. But let me give you an idea how you can construct an ellipse very easily. Those points F1 and F2, we're going to give them a special name very soon called foci. Suppose you put a nail here and here. So you just nail those down. You have a piece of paper, you nail those 2 points down. And you take a string, that's a simple string, where the length of the string is 2A. Okay, you take a string with length 2A. So you take the strings and take your pencil and stretch it. Okay, so if you stretch the string, you will get exactly this point right there. Okay, so fix those, nail them down, those they don't change. Take a string or just a simple string of length 2A. All right, and then take your pencil and stretch it a little bit. Okay, you get, usually when I teach in class, you do it in class, fairly simple. And then with the string, start moving the string. As you move the string, you're not changing the point you're getting, the sum of the distance to A. So take your hand and move the string. Move it like that, basically. And what the shape you get is absolutely this oval shape. You get this ellipse. So constructing an ellipse is actually by hand, it's fairly simple because of this definition. Our job is to do the following. If you have all those points, which are obtained this way, and you take a point xy, what's the relationship that exists between x and y? So it means what is really going on? What's an equation that exists between x and y? So that's what we are going to do right now. Find equation that relate x and y. So equation of an ellipse. Okay, the equation of an ellipse. All right. The points F1, F2 that I just talked about, the point F1 and F2 have a name, are called foci. Okay, they are called foci. And to find the equation, so how we're going to find the equation? So we're going to put the point. So we're going to put F1 and F2 on the positive x-axis. The x-axis at the following point. So F1, I'm going to put at the point minus C0, F2, C0. Okay, so to find the equation, we have to introduce x and y axes. So we're going to put F1 and F2, which we will call foci, on the x-axis at minus C and C. And now I'm going to derive the equation. So it's going to be a little bit tedious, but I will do it because I think you guys should know that equations don't come from nowhere. The equation comes from somewhere. So this is my picture for me right here. This is my point, F1, F2. And this is minus C0. So I'm going to put them right in the middle. And this is my F2, C, and 0. And this is my x and y axis. Okay, and this is this ellipse I get by stretching the string of links to A. And that's a point on the ellipse. Okay. Now I'm going to use the fact that the sum of the distance equal to A to be able to derive the equation, because that's what characterizes the point. So bear it with me a little bit. There is some math going on, simple math, but so what characterizes the point? So suppose P on the ellipse. My goal is to find an equation that relates x and y. It means the distance, the sum of the distance is equal to 2A. Okay. Now, what's the distance between P and F1? This is the point here, P, and this is F1. What's the distance between P and F1? Now that the distance formula tells me that the distance is the square root of, basically Pythagorean, the change in x between P and F1. It means how much x change. So it's x plus c squared, the change in y plus y squared. Okay, so I'm using the distance formula, which is, I remind you here from back in high school. The distance between 2 points is the square root of x1 minus x2 squared plus y1 minus y2 squared. So that's the distance between the 2 points x1, y1 and x2, y2. So in general, the distance between 2 points x1, x2 is the change between the x squared plus the change between the y, the square root of that. This is Pythagorean theorem. So here my point P is x minus c. So that's x1 is x, minus c, which is plus c, and y, and this is 0. So that's PF1. So this x plus c squared plus y squared. Okay. Now, the distance from P to F2, x minus c squared plus y squared equal to 2a. Now what I'm going to do is the following. I'm going to manipulate this algebraically. Okay, I'm going to manipulate it a lot algebraically to find a nice relationship between the x and the y. Now, whenever we have square root and we need to manipulate, we basically square to get it to the square root. So what I will do is the following. I'm going to say that the square root of that, I'm going to move this term to the other side. And you have to be careful with the algebra, because if I mess up, I can never get the equation nicely. Okay. So the idea is what happened between x and y? What the relationship? That's already a relationship, but that's really an awful one. Nobody can memorize it. So we're going to make it much simpler. So I move this, and then I'm going to square both sides. And I get, when I square this term, I will get x plus c squared plus y squared. I'm going to square this term. 2a squared is 4a squared plus this times square minus 2 times 2, 4a, the square root of that. Okay, my goal is to simplify this equation, to really, really simplify it. Now I'm going to see what I can do. I'm going to distribute here, and do some simplification. So if I distribute this, it would give me x squared plus 2cx plus y squared. And this will give me 4y squared plus x squared minus 2xc plus y squared minus the 4a, the square root of this term. Right, we're almost there, kind of. Now, x squared simplify. Y squared simplify. xc simplify. And, no, something doesn't simplify.
The 2c squareds should simplify, right?
C squared should simplify.
The xc, how if you add it to the left side, why would
Yeah,
it
that's what I'm doing. Something stupid right there. Those did not simplify because you have the plus and the minus. Okay, now that's the only thing I can simplify. Now again, I still have a square root term. I don't want to deal with it. So I'm going to put the square root term in one side and everything on the other side. So cx and cx, those will not simplify. So I'm going to bring this here. So I'm going to have 4cx and minus 4a squared equal that. Plus y squared. Now, another thing that I can simplify, I have 4, 4, and 4. I can get rid of those, and I will be left with cx minus a squared equal a, the square root of that. So it's a little bit tedious, but you will find the equation at the end of the game, the equation that the ellipse comes from. Now I'm going to square both sides and see what I get. So now square both sides. I will have this square equal this one square. All right, so let us square them on another piece of paper here for me.
What happened to the negative 4a? And you divided it by
Yeah, it actually will not matter, but you're
Okay.
absolutely correct. Yeah, so let us square. So I will have c squared x squared, right? Plus a4 minus 2cx a squared equal. When I square this, I have to square the a, and then this term here is gone by now, no more square root. Okay, so stay with me, because if I do any mistake, I'll mess up the whole equation. All right, now finally, I'm going to distribute and make this as nice as possible. So finally, I will get this plus a to the 4 equal a squared times, this give me x squared plus c squared plus y squared. Right now I'm going to distribute and collect like term, and we get our formula. So the formula is purely based on the geometry of the meaning of the ellipse. And this is gonna give me a squared x squared plus a squared c squared minus 2 a squared xc plus a squared y squared. Okay. Now let us see what we can do. Any simplification. Minus, this will cancel each other out. And now I'm going to put everything in x together, and x and y in one part, and the constant term of the other part. So this will give me the following. So the constant term would be a4 from here minus a squared c squared. And from this side, I will have a squared x squared minus c squared x squared plus a squared y squared. So this will give me. Now, if I factor out the a squared here, I will have a squared minus c squared plus a squared y squared. Okay, I am at the end of our equation. We're going to divide across divide across by this quantity here. Okay, we're going to divide across by that. Let's see what do we get. It's going to give me a 1 right there. This, if I divide by this expression, I will have x squared over a squared plus. If I divide this by this expression, I will be left with y squared over a squared minus c squared. So you can see this complicated, fairly complicated equations turned out to be much simpler, but it required a little bit of math. So finally, if we're going to set, usually not to keep it this way, we're going to set b squared to be a squared minus c squared, and then we get the following. The following equation. We get x squared over a squared plus y squared over b squared equal to 1, where, because we have to know where the b is, where b squared is a squared minus c squared. Or sometimes I like the student to remember it as c squared is equal to, if I solve for c squared, I bring c squared here, a squared minus b squared. And that would be basically the equation of the ellipse. And this is that some of you are actually, I'm sure some of you are familiar with it, but that's really the equation of the ellipse. It means that's the equation that relate. So we have this weird picture here, this weird definition. We have those two fixed points. I'm taking all the points whose sum is a constant. So what we saw that the relation that exists between every x, y is this relationship. A is from here to here, that's the 2a. That's where the a comes from. That's why we need 2a, so the formula will become easy. And then the b squared is given right there. C are the coordinate of this foci. This is the C from here to here. Okay? And that will become the equation of the ellipse. Now let us analyze it a little bit more to be able to work with it. But that's really what this formula that some of you have seen, that's where it comes from. So let us analyze this formula a little bit more.
Professor, it's 854. That's what.
Okay. Thank you very much, because I don't pay attention sometimes. And I guess you guys, after 2 semesters of being with me, some of you know that. Thanks a lot for reminding me. So now we establish the equation. Tomorrow we go from there. Thanks a lot. Okay, any questions before I let you go? Any questions?